Thanks everybody for being here. Thanks for being here at the beginning of the school year and for doing what you do. I know how hard you work, and I appreciate the time that you're spending with us today. So welcome to Get Started with Essential Chemistry Part 2, Hands-on Investigations. This webinar we're going to assume that you've attended Part 1 already, where we went over how to navigate through the Essential Chemistry curriculum. Whether you have Portal or if you're a non-Portal subscriber and you're going through education.pasco.com to get to the resources. I'll briefly touch on how to get through and find things on Portal and education.pasco.com, but I'm not going to spend too much time on that. We're going to focus on the labs, the lab component of essential chemistry, especially the sensor-based labs where we use SPARKvue and sensors, and how to use the data analysis tools, and what kinds of ways you can enrich your curriculum with them. So, hands-on investigations with sensors today. And here's our agenda. We're going to review the essential chemistry lab investigation resources. So a brief repeat. So the first few minutes might be kind of a repeat if you just attended part 1, where I'm going to show how do I get the stuff for the essential chemistry lab programs in Portal and education.pasco.com. And once I go through that, then I'm just going to move on outside of and just focus on the labs. We're going to begin with that investigation I mentioned in part 1 with the evaporative cooling, comparing why do we sweat? Why does feeling water evaporate on my arm feel different than alcohol, isopropyl alcohol? And then what does acetone look like if you're taking off nail polish? With nail polish remover, that's even more crazy feeling with temperature difference. Why? What does it have to do with molecular structure and intermolecular forces? Next, the essential chemistry equipment kits and SPARKvue, just pointing out what's in there. Some frequently asked questions about some of the components of the kit, and where do I get SPARKvue, the software that we're working with in the essential chemistry program. Then we'll look at investigation 8A, determining limiting reactants. This is the labs that I chose are ones that are like kind of the essential chemistry's greatest hits. These are the ones that teachers have told me and have told PASCO, we really love this lab the most. So I'm making sure to show those to you. It's beginning of the year, so if I've got time, I will, besides Boyle's Law, I will also introduce you to the pH sensor and an investigation or that comes early on with sensors, physical or chemical change, depending on if we have time, we'll do that. But I'm definitely going to introduce you to the pH sensor with pH of household substances, and we'll do a Boyle's Law investigation as well. So today's presentation is available here at this link, and I'm going to put that in the chat window for easy access. Now this time, if you attended part 1, I emphasized, I'm just giving you the presentation, because all the other resources you should be able to get through your login on Portal or through education.pasco.com. But this time I put a little bit more in the shared resources here. Let me show you what that looks like. So if you go to that link, you're going to see the shared Google Drive contents. In that folder, you're going to see the presentation that I'm sharing today that's on your screen. But there's also a folder called resources. And in some of the slides, I'll point to something and say, oh, there's a resource for that. There's a separate document that's kind of a cheat sheet to help guide you if it's a while before you use sensors in your classroom. So what's in there is a cheat sheet for something called shared sessions, a help document for SPARKvue, and how to calibrate the pH sensor and take care of it. This I'm going to open right now. This has how to calibrate, and also a YouTube playlist of sensor care videos. And here are the videos that are there. These are the frequently asked questions that I don't have time to go over today, but I think that you'll find valuable if you're using your pH sensor, depending on what you're using it for. So let's go back, a quick look at SPARKvue help, because yeah, you might be wondering, hey, what menu did you click to get that thing? This is what that document looks like. It is a screenshots of all the screens and then pointing out the features on each screen and what each thing does. This gets longer and longer as we add more and more features to SPARKvue. This software is deep. You can take it pretty far with analysis. It goes really far, but we're going to just scratch the surface today and go over the types of analyses and tools that are present in those essential chemistry labs. So we looked at all the labs that are in essential chemistry, and we made a list of what are the tools that are used for those specific labs in the whole program, and that's what I'm sharing with you today. So everything I'm sharing will come in handy if you do all of the labs in the program. And that's amazing if you do, because there's over 70 labs. Some are sensor-based and some are traditional. So that's what's in the shared resources folder. And again, that link, the bit.ly/2025-E, it's case sensitive, part 2, that link is in your chat. So go there to get those resources. Okay, next, the parts of the program. So you're probably here today because you did get the kit, or maybe you're curious about what was in the equipment kit for essential chemistry. So let me switch my camera so you can look at what it looks like when you receive all the things that you can possibly order. This is in addition to buying the subscription to the license to use the textbook. You can order the equipment that goes along with the sensor-based labs. So you've got these 2 bins have sensors and a periodic table, some other equipment, like, for example, I'm going to point to this on the screen. This is a condenser for when you do organic chemistry or you're doing distillation. That's what that's for. This piece right here holds up sensors on a ring stand. So you can put a temperature sensor and maybe a pH or conductivity sensor at the same time into your solution using this tool. Also, the sides have a little itty bitty nook, a little nook to put wires in for that voltage sensor on either side so that you can have wire management. All the sensors are wireless, and the only wires that you'll see are here on the voltage sensor because you need those leads for if you're doing electrochemistry in order to attach to metal electrodes. There is a couple of different choices for the equipment kit. There's the basic kit. The basic kit includes the pH sensor. We're going to use that today. Again, we'll talk about the care for it. The temperature sensor, which we're going to use first. It also comes with a pressure sensor. We're using that today. So all the stuff today is all the things in the basic kit. Also included in the basic kit, the molecular model set right here, the syringe, that coat goes with the pressure sensor and the tubing that goes along with it, and the stopper that's not pictured, and the periodic table. That's in the standard, and then in the extension kit. And by the way, if you had an older kit from the Essential Chemistry program like a few years ago, it looks slightly different. It won't have the drop counter. Now we include the drop counter. This is the drop counter right here, along with a holder for it for a ring stand and a drop. This is like a burette where it dispenses drops. So this will automatically track the volume for you, like in a titration. So that is now in the expansion kit. So this is part of the expansion kit, as well as the voltage sensor and the conductivity sensor, plus the colorimeter and turbidity sensor. So we're not going to get to the colorimeter or voltage sensor or drop counter today. We're not going to be able to cover the distiller. We may get to conductivity if we get to that. The physical or chemical change lab may or may not, but we are definitely using these 3 sensors today. Okay, so when you log into the teacher ebook, that's where you find the resources. If you're going to education.pasco.com, you can also get them at Portal. So I'm going to show briefly going into Portal. So if you're a Portal subscriber, this is a subscription service that helps you manage your content and helps you pull resources into your whatever system you're using, like Canvas or maybe you're using Google Classroom. But that's what this service is for. You could click one of these links if your IT has set you up to communicate with the Portal app. Or you can log in with your email if you're like me and you are not a classroom teacher and you have the resources, but you don't have a Canvas account. So I'm going to log in with my email, but once you log into your learning management system or your Canvas, for example, you'll see something like this when you go to the modules. So this is, I've got some items pinned here. We're going to do this lab evaporative cooling today. That's our first lab. The resources for the lab, I'm going to quickly go up here to menu on the right and go to curriculum and go to PASCO Essential Science. And we're going to choose Essential Chemistry. And The chapter resources, the ones that you are if you're using your, if you're trying to push the resources to students through like a Canvas account, you're going to want to go through here, view chapter resources, and then you'll see this type of menu. And we're going to do the energy and change lab from this chapter in the first lesson. And the lab is at the bottom. In the investigations section, which is at the bottom, and we're doing the evaporative cooling lab. If I wanted to, I could favorite it so that it shows up in the favorites list. And here's the lab itself. So there is student-facing video here. This is just how to use SPARKvue software, and a teacher-facing video here, which the teacher-facing videos just describe what's coming, what's going to be available in the lab. What are we going over? What's the equipment like a 5-minute thing for you to look at and decide whether or not you'd want to try out this lab. Just check it out. So here's where you would select resources and share with students. Either you can, if you select something that's downloadable, it'll let you download it. If that's how you share resources, maybe you're having to download files to your local computer and then you share from your computer into your system, if that's the way you work. Or if you're hooked in with your, like your Canvas, there's the option to import these items into a module. Or if you have Google Classroom, you can push straight to Google Classroom from here. Okay, so that's how you get stuff for labs from Portal to your system. There's another way to get stuff from Portal to your system, but it's more along the lines of what you do if you went to education.pasco.com. So let's say you're not a Portal subscriber, you have Essential Chemistry, but the way you get there is this way. You go to education.pasco.com and you've already logged into your teacher account. Again, if you're not sure how to get there and do all this stuff, then I would recommend looking at part 1 of this training series. And then you can open the book. This is a teacher login. You click open the book, and now you can go to lab, and you can navigate to chapter 11. And we're doing the evaporative cooling lab. And then all the resources are here in the teacher edition on the left side, in the yellow area, where a presentation is provided that goes along with the lab. And that is, if you want a step-by-step walkthrough for students, this helps students who need a lot of support, you give them a lab write-up and a lab procedure and they have trouble following it. You can, at the same time as giving them the procedure, do the step-by-step walkthrough with the presentation. That's what this is. But the nice thing about these presentations, every lab has these, the think about it slide. The think about it slide just gives a scenario or some phenomena-based event that helps students think about the science behind what they're about to explore. It helps them prepare and it helps them gain interest in the activity they're about to do. And then the teacher answer is there, right? You hover over it or you can click it and it gives you the note, like a hint about how to answer that item. So here's all of it looks just like the lab right up here. All the steps are the same. Let me get out of this. The steps to the lab are here in the student lab directions. So here's a PDF version of that. So again, you can download, print it out, or you can share it or push it or pull it, however your system works for sharing documents with your students. You could also download the docx and edit it if you want to make it your own. Maybe you need to add steps. Maybe you want to remove steps. Maybe you want to make this inquiry and make the students come up with the procedure. You can do that because we give you the editable files. The answer sheet is for students to write answers on. If you click the Google Slide option, it's just a preview. You would have to make a copy. But the advantage of using this version is all the stuff that's in the background, students can't accidentally click it. It's not like a Google Doc where they can accidentally click and type over things. This is an image, but all the type here parts are where students would enter content. So it's kind of a lot more structure to help students get this answer sheet filled out as they're doing the lab. And the answer sheet for teachers is here too, answer keys. If it is a SPARKvue or sensor-based lab, then there'll also be a sample data file that you can download and open and see what does it look like, what should I expect on data, but that's also showing up in the teacher answer key. Again, there's that video again of what is this lab all about? What's it look like? Do I want to do it? And then some reference items like safety and SPARKvue references. Also, lab preparation notes in the teacher edition for the teacher to be prepared, everything they need to know to make solutions, to prepare equipment, to be successful in the lab. And then as you page through the lab, there'll be answers here, which I'm not going to show on this screen. Okay, so that's all going for non-portal subscribers. You can go through education.pasco.com. All those same resources are here in Portal. But this again makes it easy to put to pull into your managed classroom, or you can get to the ebook this way in Portal. You go to Menu, Curriculum, PASCO Essential Science, back to the screen, go to Essential Chemistry, and instead of the View Chapter Resources, which help me push or pull resources, then you would launch the teacher ebook. And now we're in that same place where I just showed you how to get to the labs, to lab 11 and so on. So eventually you can get to the same place. You just have more options with Portal. So that's all about that, all the management stuff. We're going to shift now and do all lab stuff. Okay, so here we go. Oh, by the way, please feel free to ask questions, chat, or Q&A as we're going along. I'll try and remember to glance over at my chat and Q&A section. So back to the presentation. Excuse me. Let me find that. Getting there. There it is. Okay. Part of the essential chemistry program, we covered this in part 1 of the training, the infinite test bank. I'm not going to go over that today. PASCO Academy Chemistry, I'll review that if we have time. But there is information on this in part 1, webinar part 1. So check that out on PASCO's website under the training pre-recorded resources to see that. Also, if you attended part 1, the recording will come to you if you signed up. Okay. SPARKvue is also part of the Essential Chemistry program. I guess I lied about not showing where resources are. And I need to show you where to get SPARKvue. I forgot about that. So let me go back to Portal real quick and show you how to get there in Portal and also from Essential Chemistry. So here I am in Portal. I'm on the dashboard. This is where you land when you first log in. On Menu, if you go to Support, that's where software help and downloads are. That's where you're going to find all the software. So if you're Portal, all the software is here, even though stuff you have to buy. So another advantage of being a Portal subscriber, you not only get the Essential Chemistry and Essential Physics curriculum, you also get the Academy and all the software, including Capstone, including ChemView, the chemistry-specific app that is normally you would pay for this separately, but it's included in a Portal subscription. Then there's spectrometry, match graph, and coding Python library and data streamer, which works with Excel. So all these options, but SPARKvue is the one we're using today. Okay, so you would go again, Menu, Support, Software Help and Downloads. That's where you get it. And this is the licensed version that you'll be using in your classroom. Now, if you're not a Portal user and you're using education.pasco.com, to get the Essential Chemistry curriculum, you just go to your login page and on education.pasco.com, you scroll down, keep scrolling. And by the way, there's some nice video guides here to help you with using SPARKvue software. It's available to students and teachers. Then there's a section that says SPARKvue software for data collection and analysis. So you can use SPARKvue from your browser at sparkvue.pasco.com. I put that in the chat earlier, but I'm going to put it in the chat again. I think I forgot to put it. This will show up on my slides in a minute, but I'm going to add that into the chat again. Sparkvue.pasco.com is how you get the browser-based version of SPARKvue. It's free everywhere on everything. It tells you what it works on here on the screen. So if you're curious about, oh, it's going to work on my Chromebooks. Yes, it's going to work on your Chromebooks. So there's that. Then there's also, if you want the licensed version because you're running it SPARKvue on Windows or Mac computers, here's where you download those right here. And otherwise you get it from your app store. If you're using a phone or tablet and you want the non-browser version, you can do that. There's also where you get to PASCO Academy. Okay, so I'm going to close this window and we're going back to this presentation. All right, I already went through these items, answer keys, reference materials, and where to get videos, all covered already. So now we can do the lab. The first lab we're doing is the evaporative cooling lab. And I chose this one because I like starting with the temperature sensor. I'm going to switch my camera now. I like starting with the temperature sensor because it's kind of a low bar to get into sensors if you're for students or teachers. And by the way, if you're watching this live, you should see a gray bar that's dividing the shared screen and the video. You can drag the hover on the space between the video and the gray bar and the shared screen, and you can drag to change the size of the video to make it bigger or smaller based on your preference. And that's only if you're watching this live. If you're watching the recording, sorry, it's fixed where it's at. You can't change it after the fact. So here we are doing the 11A evaporative cooling lab. It uses the temperature sensor. And cotton ball, the molecular model set, and some water, isopropyl alcohol, and acetone. And the first part of the lab, which I'm going to skip, I'll just describe what happens. So the students get a cotton ball. They have 2 cotton balls. They put one in water, and they wipe the inside of the forearm, and they describe what they feel. So they're getting some sensation, and they're describing it, and they should feel it. Hey, it's feeling really cool where the water's evaporating off my arm. And then eventually all evaporates. Then they get a second cotton ball and do the same thing with the isopropyl alcohol on the opposite arm. And they wipe it and they say, wow, it's evaporating a lot faster and it feels really cold compared to the water. They don't do that with the acetone. But if you wanted to throw that in there, I suppose you could. It is the nail polish remover. So students might have experience with that. Hey, you ever use nail polish remover? What does that feel like? Oh, it's really cold. So they might have some experience there. So that's the first part of the lab. Then the second part is sensor-based. So now I'm going to show how to get sensors connected to SPARKvue and how to use labs in essential chemistry. Now, all the labs in essential chemistry have a step that looks like this. Open the 11A evaporative cooling lab file in SPARKvue. Almost exactly the wording, and it's going to have whatever lab name here. Now, let me show you what that actually means. So they're going to open SPARKvue, however they open SPARKvue, whatever device they're on. So they open SPARKvue. And they go to this button, Open PASCO Experiment. I'm hovering off and on so that you can see it turn blue. It's kind of bottom left corner there, bottom left corner option. So they click that button, and then they go to Essential Chemistry. That makes sense. That's the program they're in. And then they look for whatever the lab was, and they're numbered to help locate. So it was 11A evaporative cooling. So the lab, all the labs that are sensor-based are pre-built, pre-designed, pre-set up. So it's quick and easy for students to just get into the data collection and start analyzing and understanding phenomena. So then they click OK, and it opens. The next thing they do is they connect the sensor. All the sensors are wireless, so you turn the sensor on. And by the way, this sensor is a battery-powered sensor, and you can tell because on the back it has a battery door. It tells you what the battery number is when it's time to replace it. And these batteries last pretty long time, depending on the type of sensor it is. The temperature sensor it doesn't use too much power. I've had this one for years, and it's barely starting to tell me I've got a low battery. It really depends on how much you use it. That red light that's flashing right now, let me see if you can see if I move closer there. There's a red light flashing right where my thumb is, and that means it's ready to pair. So what students then do is they go to the Bluetooth icon in SPARKvue at the top right here, where it has a Bluetooth icon, and they click it, and they locate their sensor in the list. And of course, if you have a classroom full of these, there's going to be a ton of temperature sensors. So how do they know which one is theirs? Well, there's 2 ways. First of all, if you're on a Windows computer or if you're running the app version rather than the browser-based version, they will see their sensor at the top of the list. And because it's proximity-based, as long as their sensor is the closest sensor to their device. The other way is there's a 6-digit code, 893528 is my sensor, that matches right next to the flashing light. So there it is. I know that's mine, and I just tap to connect. And if somebody either accidentally or on purpose grabs somebody else's sensor, the sensor owner can either just turn it off to disconnect it and then reconnect on their own, or if you accidentally grab somebody's and you know you did, you can always hit the X to disconnect it so that there's no issues with accidental sensor swapping. Okay, so we click done. All right, so the lab says to set the sensor in the water for about a minute to let it come to equilibrium. And when you look at SPARKvue, follow where my cursor is. That is a live reading. It's not recording data, but it's giving you a live value, so you have an idea of whether the sensor is still changing temperature or not. But for time's sake, we tell them at least a minute. If they wanted to wait longer, they could. So there's that live reading. Okay, so we call this a live data bar. Let's pretend it's been a minute. So the directions say to hit start at the same time as you pull the sensor out. So you actually kind of want to pull it out. Sorry, you actually want to hit start before you pull it out so that you get the baseline temperature. Start, and then pull the sensor out and hold it steady. And I'm showing you on the camera what that looks like while SPARKvue is going and showing you the data. So when students make the observation of what does the sensor look like, you can barely see it in the camera, but there is a drop of water hanging off of the bottom. And the temperature is going down. And students would have predicted, what do they think is going to happen when you take the sensor out? Then law will say, well, it's going to be the same temperature because that's room temperature water and it's been sitting there all day. But then they see this and they're like, why is it decreasing? And eventually they come to the idea, oh, it's evaporating. Like on my arm when I did the cotton ball and it felt cooler, actually felt cooler. Oh, it really was getting cooler while it was evaporating. I have the data to back up my experience here. And what SPARKvue is doing, so meanwhile, they're looking at the drop of water on the sensor tip and then writing their observations. And then SPARKvue, meanwhile, is going to automatically stop. Watch the timer on the bottom near the stop. See how it stopped on its own? I didn't hit stop. It on its own stopped after 1 minute. That's how this experiment file is set up, is to help save time and set up. Then the directions say to dry the sensor. Try to do that without touching it. So dry off the sensor. Students can open up the toolbar and use the auto scale button so they see the whole data, and this follows the rules that we teach students about graphing. You obviously would have taught students those graphing directions of always put a title. Use an appropriate range for your data on both y-axis and x-axis. Increase at regular intervals. Put a label with units when units are part of your measurement on your x and your y-axis. So all the rules. Use a legend, all of them. Here's a whole bunch more analysis tools. We're not going to get to all of them today, but just the ones that we use in essential chemistry labs. Okay, so there's that. That was that run. Now the next run says, let your sensor sit for 1 minute, come to equilibrium in the isopropyl alcohol, predict what you think will happen. And after a minute, take that sensor out of the solution and watch what happens while you're recording that 1 minute run of data. And this time I'm going to wait a little bit because I see the temperature changing. And I'm going to pretend it's been a minute and we're going to hit start and watch what happens. So here is the tip for isopropyl alcohol. I see another drop at the tip of the sensor, but it's smaller and it looks like it wants to fall off. Oh, look, you can already tell looking at the shape of the line, that slope or that shape, it's really quickly declining. And it looks like my first run disappeared, but all I have to do is check mark it in the legend to make it come back. You can hide runs. It doesn't delete it, it just hides it. And it's kind of an eye opener of like, wow, look, I wasn't imagining it. It was way cooler on my arm when I did the isopropyl alcohol. I can see, even though it started warmer, and that was my fault for not bringing the solution out of the closet in time into this cooler room. And this can also sometimes happen based on like pressure and humidity. But I see that it decreased and got colder. It did get, even though it started warmer, it got colder. And we're waiting for a minute. And students are looking at that drop and saying, wait, it's really small now on the end of that sensor. Okay, so then they dry the sensor and they are going to do now the run with acetone. So again, let that sit there for a minute, and you can even see, and if you can see that tiny number there on the preview, it's colder than all of the other ones. So I'm going to hit start. Pretend it's a minute for time's sake. We're going to just pretend it's a minute for acetone. Predict what's going to happen. Let's see what happens. Go. Okay, so now acetone. Oh, wow, that's really sharply declining. And you can hardly see liquid on the end of the sensor. You can hardly see it. And the way this goes, sometimes the data looks completely different, but it's consistent in that acetone is going to give you the sharpest decrease. Sometimes it's really dry and it evaporates very quickly, and it's already all evaporated. You can tell, look at the temperature's actually going up now. If you look at the tip of the probe, there is no liquid left at all. There's nothing left on the probe tip to keep the temperature down, so temperature's going up, and this is a nice demonstration of how the properties of all these liquids vary based on what's dissolved in them, if anything. Water is just water. Isopropyl alcohol is a mixture of mostly isopropyl alcohol plus water, and this is 100% acetone, and it completely evaporated within 20 seconds. It was gone. And holding perfectly still, because if they move, they're going to, bias the data a little bit. So there's 3 runs of data just like that. Very quickly, we can do part 3 of the lab, where it tells them to use our molecular model set that comes with essential chemistry and build water. Now build isopropyl alcohol. Now build acetone. Now look for a pattern. What do you see on all the molecules? What do you not see on all the molecules? So they're looking for patterns, and the first thing they're going to pick up is that oxygen, oxygen, oxygen. We see 2 hydrogens, 1 hydrogen, no hydrogens. They're going to see that pattern and be able to attribute the behavior they saw and the behavior they experienced on their arm, their qualitative and quantitative data, and connect it to the bonding, the hydrogen bonding and intermolecular forces, and put it all together and figure out by experience and by data that the OH bond has an impact on evaporation. So that's a super fun lab. Good way to introduce sensors. Is even something that you can do on the first day of school, because like you don't have to wait until they know about bonding. They can wonder about this, right? Show them this data, go through the data collection, have some volunteers help you out, get them wondering why is this happening? And then eventually get here to chapter 11. Okay, so again, questions in chat or Q&A if you have any, and I'm going to move right along then. So I'm going to go back to the presentation to make sure that I'm not forgetting to cover some things. So again, we're going to go to the open PASCO lab in SPARKvue to open the 11A evaporative cooling lab, and then follow the directions that are in the document that goes with this lab. I already talked about the kits, so I'm going to skip this slide. Okay. If you go to education.pasco.com or PASCO portal, I pointed you to support and software help and downloads, and that's where you get the SPARKvue software app. And App Store if you have an Android phone or tablet or iPad. Okay. For your Chromebooks, most teachers have Chromebooks, but whatever you have, the student version can be, except for iPhones. The student version, you can get it from sparkvue.pasco.com. Chrome or Edge are the better browsers to use there. Chrome is the better for all of the program, for all of Essential Chemistry, including SPARKvue, if you're using the browser-based version of SPARKvue. Some help videos, whoops, let me go back one. If you want to, let me see if it'll let me copy this. Nope. Okay, well, let me click the link. And my link is concerned about my link. Okay, so if you click that link, if you go here, I'm going to put that link in chat so that you can get there right now if you want to. Okay. So there's the link I just went to. This takes you to the How Do I channel of, and it's already preset to go to the SPARKvue Progressive Web App, the PWA. So you see this logo on the video that says SPARKvue PWA. Sorry, I'm pointing my mouse right at it, but it turns gray. So when you see that logo that says SPARKvue PWA, that means it's a video that's made specifically to explain how to do that thing, like clear the Chromecast to reset your SPARKvue, if you need to do that, or connect a wired sensor in the SPARKvue PWA. It tells you how to do that thing in the browser-based version. There's also a logo at the top of the video to help you distinguish that, oh, this is the browser-based version directions. Okay, so that's for Chrome users, and for anybody, I preferably can use this in the classroom, because you always get the advantage of using the browser-based version is it's always up to date. When you open it, it's going to be the updated version. You don't have to worry about the app updating and getting apps pushed to your device or whatever. Just go to the browser-based version. It is the most up-to-date version. Okay, so there's help for you. Again, a reiteration when you're opening SPARKvue and you're doing essential chemistry lab investigations and it tells you to open the lab, you go to the PASCO experiment button and you pick the lab. Okay, I had mentioned before I'd started recording, I said, hey, if you want to participate in this thing called shared sessions, get SPARKvue and I'll cue you when it's time. Well, now it's time. So if you're watching live, you'll be able to participate in this if you want. So if you are interested in seeing this live data that I'm collecting here at PASCO, if you want to see it on your own device, I recommend getting a second device, not the one that you're watching on right now. Get like your phone or something and go to your browser and go to the SPARKvue browser-based version of the app. I'm going to put it in chat again, so it's the most recent link, sparkvue.pasco.com. And if you do that, I'm going to do something called the shared session. So I'm going to start collecting data and I'm going to share it with you. So actually, before I even do that, before we do this lab, I'm going to show you some analysis tools from our last piece of data, this data. I'm going to share this with you right now. Okay, so here's what I'm doing. And I'm going to switch to my phone. Let's see, switch my camera to the phone. How about this camera? So I'm going to get on my phone. I have the SPARKvue app on my phone. So my phone will show up again on the screen. Here you go. My phone is, this is what you're going to do. So follow what I'm doing on my phone is what you're doing on your device. Meanwhile, I'm a second person here. So I'm like two people. Let's say I'm the teacher. You don't have to be a teacher. Let's say I'm the teacher. I want to take my data and share it with you. So as the teacher, I'm going to go up here. So you're just watching what I'm doing. As a teacher, I'm going up to the hamburger menu in SPARKvue. And I'm going to choose shared session. Again, let me show that one more time. I go to the hamburger menu and I choose shared session as a teacher. So you're just watching right now. And I'm going to start the shared session because I'm the one that has the data that wants to send it out to everybody. So I'm going to start it. I'm Barb 1 because there's two of me. So I'm Barb 1. My session name, and this is the part you have to remember. You have to remember session name. It's going to be CAT, C-A-T, all lowercase. And when you're doing this, I recommend choosing a session name that's easy to remember, easy to spell, all lowercase. So CAT, remember CAT, okay? All right, so now I'm doing this shared session. You guys who are wanting to participate, you on your device, go to the hamburger menu, go to shared session. You are going to choose the top option, manually connect to an open session. Top option, manually connect to an open session. Click it. Put your name, please, nothing inappropriate, because I won't approve you if you have an inappropriate name. I'm going to put Barb 2 as my name. You could leave my name blank if you like. And then the session name, remember it was CAT, C-A-T, put in CAT for session name. And then say OK. And see, while you guys are popping up here, there's connected user, that's me, my teacher screen. And you guys who are waiting for approval, here's you guys. If I hit the little orange icon with the no sign, that means I'm not letting you in because your name's inappropriate for or whatever. But if I hit the green check mark, I can one at a time approve you, or I can hit the approve all button. So I hit approve all. That means everybody who signed up so far is in my session. And as more people try to get in, I can OK you and let you in. And what do you see on your screen? You see my screen on your screen, don't you? Even though you're not here at PASCO headquarters in Roseville, you've got this data that I have already collected. Cool, right? Okay, so if there's any more users out there, please pop in now because I'm going to switch my focus to doing the analysis. So, okay, that is, this also, I'm going to start another run so you can see what it looks like when I just collect live data. Look, I'm doing run 4. Oh, look, you can see my data live. It's on your device. Yay. Isn't that neat? Can we save that data to our own devices is the question, and the answer is yes. I will get to how to save stuff in just a second. So there is, I'm going to show all the runs. Run 4 is kind of some junk data, but I'm going to hit stop. So look, you got that live too, right? Cool. Okay, well, I am going to do some analysis, and the first analysis tool we're going to use is the coordinate tool. What is this data point coordinate on this last red data point? All I have to do is click it and choose the coordinates tool, and it gives me the X time, Y temperature value, XY value for individual data points. And the little buttons around the XY bubble go away, But if I click it, I can get them back and no problem. And I get them back, I can hit the arrow button to go left, to go right, to get 1 point at a time. I can get rid of it by touching it, hitting the X. So that is the coordinate tool. So I can either get that by touching a data point and turning on the coordinate tool, or I can go to the menu down below here and click coordinate tool. But what if I wanted to add a coordinate to the green run? It won't let me do anything to the green run. Everything I do lands on that red run, no matter how hard I try. But that's because I have to tell SPARKvue that I want to do analysis on the green run. So I go up to the legend up here and I select the green run. Now that that red box is selected around the green run, now I can do analysis on there and use that coordinate tool. Okay, I'm going to disconnect everybody from the session now so that I can have your attention up front. So here's what I'm doing. I'm saying, okay, I'm disconnecting you from the session. Okay, now you have the file, right? It's yours now. So now you can do your own analysis. I'm no longer controlling your screen. You can touch the data, you can change runs, you can explore tools, and then if you want to explore some of this data later, you can save it. Yes, you can save it to your device. So if you're on the cloud, a cloud-based account, you can save it to your like say you're in your Google account, you can save to your Google Drive and open it later. Or if you're on like a Windows computer, I can do save as and put it on my desktop where everything else in the world lives. And if I close it, if I close my file, I can go back and open it later. So let me find it again from my desktop. It's called My Experiment. You can rename it whatever you want. And there it is with the whatever tools I had on, still there. All the analysis I already did, still saved. So that's one option for saving. Students and teachers have the ability to save. Students and teachers have the ability to do sharing with a shared session. And you can save it to anywhere you're able to save on your device and reopen it at any other time. And the more analysis you do, the more it'll save. So there's that. Any other questions before I move on with more tools? Okay. Okay. Next, some more tools that you'll be using in SPARKvue. So there's the coordinate tool, but really you might have noticed that, let me turn off run 4. You might have noticed that when I click that coordinate tool, there's a little delta button. And delta it is indeed. Okay, so delta, when I turn that on, when I turn on delta, it makes this gray box with a second handle. And if I drag it, it live updates and tells me the delta Y and delta X, the change in Y, the change in X, the change in temperature, the change in time. And you can be like, oh, I could do slope, right? Rise over run, Y over delta X. There's a better way to do slope, but yes, you can do it that way. And it gave me a negative number here for delta Y because it dropped. There's a great way to teach students about slopes, about decreasing and increasing, and remembering to be faithful with the negative number because it's final minus initial. Delta is final minus initial. That's why it's negative, because the final temp was lower than the initial temp. So that's why I have a negative delta Y. My time, though, is positive because, time is positive. But actually, you can, if you do the order a little bit different, for example, let's say that my first point is here, my initial is here, and my final is here. If I do this, which sometimes students accidentally do that, they switch their initial and their final, it will give you a negative time. It's only doing what you're telling it to do. So make sure that when you use delta, initial is the first data point that you want as initial. The second box is your final, because it's always going to do final minus initial. So that's the delta tool. That's how we get the change in XY value by doing it quick and easy. Or if you really want your students instead to do the subtraction, you can just put 2 coordinate points. Like here's one coordinate and there's another coordinate, and I can put them on the points that I care about and then subtract that way. So that's another way to do delta. Oh, before I forget, I wanted to remind you that the shared session that we just did, there's a handout in your shared resources folder. There's a little visual guide of how to get that shared session to work. So you can do that in your own classroom. Okay, now I said there was an easier or better way, rather, a more less error way to do slope. And many of the labs ask students to do slope. Before I do slope, I'm going to real quick show you other ways to select data besides doing the coordinate tool. So let's say that I want just to analyze the sharpest part, or maybe just the first 5 seconds of every run. So I want to select just the first 5 seconds of each run. Then I'm going to change from this hand icon, which by the way, it's orange. And with the hand, when you're on hand, what it means is you can left click, drag, and move your graph paper around as if it was like an actual piece of graph paper and move it. And you might get lost. And if you get lost, it's not a problem because you have this scale tool. You just hit that auto scale tool. Whoops. You hit the auto scale tool and it will show up all your data in the middle again. So again, I have it on the grabbing, moving selection. I want to change from move mode to selection mode. So I tap that button and now I have a orange box around that selection icon. And I can now go to the top left of, I'm on run 3 on the pink run, and I can select the data that I care about the first 5 seconds. And it draws the box the same color as the run, so you know that you're on the right run. And also it highlights the data points that are included in that selection. And now when I do analysis, it'll do it only on that data. So for example, what if I want to look in the statistics button and find out what is the highest value out of all that data? The highest value, it's not pointing to it, but it says the highest value is 22.26 degrees Celsius, which you would have to look at the y-axis to get. But if I take away that selection, actually it's going to be the same. Let me change that from maximum to minimum. That works better for my example. Let's just put max, minimum, mean, all three. Okay. So now it's giving me these 3 values, max, minimum, and mean temperatures for just the data selection. But if I take off the selection by tapping the box and hitting the X, it gives me for the whole run. What are those values? The highest on the whole run is the 22.26. The lowest is 17.21. So it's a quick and easy way to get the minimum temperatures by turning on the stats tool for minimum, or the average of all the data points, which in this case is not that useful. But if we do a selection, maybe we care about just what is in the first 5 seconds, the lowest point. Now the minimum goes to 19.03 and gives me those values for just the selected data. So the other nice thing about being able to select some of the data is the analysis like a linear fit. Let's go to the fits button. That is right next to the sigma. And I just put a linear fit because this particular button is specifically a linear fit. Most of the time, you're going to be using a linear fit if it asks you to do analysis with fitting. Why would you be doing that? You might be thinking, well, my students are not going to do that. I encourage you to do fits because pretty much all the standards in the world now want you to look at how to talk about mathematical modeling with your students. And that's what this is. A linear fit is a mathematical model. It's an equation that fits the data or not. and how do we get these equations? How do we interpret these equations? And how do we evaluate whether they're good models for our data or not? Well, there's more than one type of fit. Let's turn off the linear fit and go to the second graph button with the line through it, a curve fit menu, which has a linear fit. So if you look at the graph here, it shows you, hey, does my data look like a straight line like this? That might be a good mathematical model. This math might be right to fit my data. Well, let's look at another fit. Well, look at this math model. This math might be right to fit my data if my data looks like that. What if my data looks like that or that? This is a nice easier way to get students to understand what it means to do mathematical modeling without having to say that word mathematical modeling. All it is look at my data, what equation for what line is the best fit. And then when I do find out what that model is, then I can make predictions about either the X or the Y value. So it's a way of making predictions. It's a way of looking at the relationships between the X and the Y measurements. This is what we mean when we say mathematical modeling. And I think the sensor-based labs really help guide students to understanding of what that is. So I do hope you choose to use this tool. It's in the labs. It tells students, hey, try this fit, try that fit. What's the equation? What does it mean? And then the interpretation of this, so linear fit, y equals mx plus b. This is the equation for a straight line. Why? well, what's Y? Well, look at your graph. Look at Y. Y. Oh, that's temperature. Okay, temperature is Y. M is the slope. I've got a negative slope. Okay, so I'm decreasing, and the slope just means the relationship between the X and Y variable. So I've got a decreasing relationship at a rate, or a rate because it's versus time, at a rate of negative 0.770. So M slope actually has units. It's units of Y over X. So M, the rate, is saying that the temperature is changing by a drop of 0.770 degrees per second in this selected area of data. And I can say that with confidence because I've got this R value here that's very close to -1. It can be close to -1 or +1. 0.992, that's pretty much -1. That means it's a really good fit. And I could tell by the R value and also by the visual evaluation, oh, my straight line totally overlaps my data. My root mean square error, that means if I look at the line, that means my data points are probably not really far away from the predicted and actual values are very close to each other. So it's a good model, it's a good fit. This equation fits my data. This is an appropriate model, and I use R and RMSE to evaluate that. So hopefully you explore that with your students. It is written in the labs, not all of them, but many of them. Okay, so that is just one model, linear fit. Well, again, most of the time, almost all the analysis you're doing in the essential chemistry labs is you're looking at delta, you're looking at initial, you're looking at final, and you're looking at slope. That's mostly what you're going to be using. So now let's just do some more labs using those tools and getting some practice in. Okay, here we go. So let's look at a new lab. I think the next one was going to be the stoichiometry lab. Let me take a look at my presentation and make sure. Yes, okay. Investigation 8D, determining limiting reactants. Okay, back to SPARKvue. Okay, so this investigation, I'm gonna start a new experiment here in SPARKvue. And by the way, if you do more than one on Chromebooks tend to have a lot of apps on them. And sometimes memory can be an issue. It can make things a little wonky. So if your devices, that have memory issues, they load weird or it just runs weird, I recommend closing SPARKvue, completely close out of it and reopen it before you do a second investigation. They're fine one at a time, but if you've got memory issues, you definitely want to keep doing that. Open and close SPARKvue. So remember how we get to essential chemistry lab? I said it was 8D. So we're going to go to Open PASCO experiment, essential chemistry, and 8D, determining limiting reactants. Okay, this lab is one of our most popular labs. When we do this at like NSTA, we run out of seats. It's very popular. So this lab looks at, sorry, I've got my camera on this same setup here. I'm going to swap out my setup. So this lab looks at what is the excess and what is the limiting reactant through the course of a reaction as we're changing components of the reaction, not the identity of the stuff, but like the concentration of the reactants, or one of the reactants. So here's the setup for the lab. Every run, I'm going to do 5 runs. Every run uses a 0.12 molar solution of baking soda solution, so sodium bicarbonate, and that's constant. All 5 runs are going to use that volume and that concentration. What you're going to vary is the acid that you react with the base. So this is a weak acid, weak base reaction. And what it's going to do, you're going to add the citric acid to the liquid baking soda solution. Gonna attach the pressure sensor to the stopper and tubing. All this is included. And you're going to dump in the solid, quick close it, and swirl it until you have a final pressure. We're using the pressure sensor because this is a weak acid, weak base reaction. We're going to get CO2 as a product, and CO2 is a gas, and we can measure its production with the pressure sensor. So we're going to do one run with 0.1 gram of citric acid in the 40 milliliters of baking soda solution and see what we get with our delta pressure. That gives us an idea of how much CO2 is produced. Then we run it again with 0.2 grams, then 0.3 grams, and we look and see when do we stop making more CO2 to determine where is the ideal proportion of reactants. And then we can figure out, once we know the grams, that's ideal, then we can convert that to moles And then when we know moles, we can compare moles to moles and figure out the actual coefficients on the reaction and balance the reaction with just quantitative data. So that's kind of the gist of the lab here. So let me show how to use your equipment to get the data. So again, we opened 8D. We're going to connect the sensor with the Bluetooth menu. This is a non-battery, non-lithium battery. It is a rechargeable sensor, and you can tell because it has a port for charging via USB. So if you forget to charge all your sensors, it always works best when you 100% charge them the night before, and they'll last all day. But if you forgot to charge them, you can always plug it in with USB and use it that way, connect it to power. So that is an option for you. Connect the sensor and say done. And now we're ready to start. So I'm going to be my own lab partner here, and it might be a little slow in getting the lab going, but that's okay. I can hit start before I even get any gas because I do need the background pressure. So I hit start. And now I'm going to put in all of my solid, close it, and kind of hang on to the stopper at the top. So you can see that my hand up here is anchoring the stopper to the top because I don't know if it's going to pop off, right? I'm working with the gas. I have to be careful. And I'm going to observe my swishing and make sure that it's effective and note how fast I'm going because I want to try and replicate this exact speed on all the runs. So as lab partners are working together, they're remembering these things and we're watching the data go. Pressure's a bit high today, 102. It's over 102 up here in Sacramento area. It's a nice day. Beautiful weather here, a bit warm. And yes, this pressure sensor is sensitive enough. So if the students are not paying attention, they do this and they squeeze the bottle, that shows up in the data. Okay, so it's sensitive. So students are carefully collecting the data, and I'm not worried about that. If that happens, it happens. I've got tools where I can analyze without having to touch that data that looks weird. Right? And we can explain what happened. The data tells a story. We can explain why there's bumps in that data. Well, we squished the bottle and that changed the volume. And we know in a gas, if you reduce the volume, we're going to increase the pressure. And there's the evidence right there. That's what happened. There's actually a tool in SPARKvue also that lets you annotate or write a note on a piece of data where something looks weird or like there's an anomaly in your data and you need to explain what happened. You can put a note right there on the graph, which I'll show you once we're done collecting. And we can see that the slope or the steepness of the curve is slowing down, getting slower. It's probably going to flatten out. So students do the run until the pressure stabilizes. And if the pressure never stabilizes, like if it starts dropping, that means they have a leak. So again, the data tells a story. If I have a leak, I'm never going to get to a stable pressure because the gas is escaping. And they can also use the graph to gauge whether or not it's stable because you've got a straight line here and you can compare your data line. Is it parallel yet? And when it's parallel, that's when it's stable. It's getting close. And for the sake of time, I'm going to hit stop because it's close enough. So students then carefully listen for the bloop. Here it goes. You can probably barely hear that. Students open it up to release the pressure after they stop collecting data. Guess what tool you're going to use here? That's right, coordinate. And you're going to find the change in pressure. So the initial pressure is 102.0 kPa. I can either put a second coordinate and do the math, or I can use my delta tool, which I am going to do. And the change in pressure here was 5.7 kilopascals for run 1 with 0.1 grams. So I'm going to go to my next page in SPARKvue. So look, it tells you to go to page 2 in SPARKvue. That means there's arrows at the top of the page. This happens to have 2 pages. Okay, so the directions in SPARKvue, then the directions that you print out from Essential Chemistry tell you to put the actual mass that you measured. I actually had 0.11 grams of citric acid there. And my pressure difference, let's see, it was 5.7 kPa. So watch what happens to the graph. Okay, it's green. It might be hard to see, but it put that data point right there. There's the X, Y. Okay, so the mass is the X. The Y is the change in pressure. Mass is the X. Change in pressure is the Y. So it graphed that point for me on the graph right there. Then the next run is going to be doubling the mass, 0.2. What happens to pressure if I double the mass? What happens when I triple? When I quadruple, and so on? Well, because I want to save time, I'm going to open a pre-saved data file. of this data already done. And here's what that looks like. We're going to turn off all these other ones. So here's the 0.1 run, and these are exact value. I got exactly 0.10 when I did this set of data. And my delta was, I wrote it down ahead of time, 5.50 on this run. That was yesterday. It was a little bit lower pressure. So 5.50. Oops. If that let me type. There it goes. 5.50. And there's that first data point there. The second run, look, I doubled my grams of citric acid. I got double the pressure. Oh, look at that. I can kind of have predicted that. And when you get the delta for that run, you get 11.20, which is just about double. And the change in pressure. And look, it's made a graph for me. It's connected the 2 points that I have so far. Third run, I triple it. Do I get triple the pressure? Yeah, just about. I get just about triple the pressure, roughly. And the delta for that run, that is 15.8. And it's still going up. Okay, what does that mean? Well, let's take a look at it in a second. 0.4. Oh, I didn't get quadruple the pressure. Something's going on between run 3 and 4 here. Okay, so let's graph what we got on 0.4 grams. We got 16.20 was my delta. It's a little higher, but I mean, not appreciably, not like it's not shooting up. And you can see on the graph, it's kind of level, almost level. And then when we did the 0.5 grams, we got the same, which happens to be a 16.10. And looking at this graph, we can see that by run 3, we're kind of leveling off at run 3. So that means run 3, that the 0.33 grams, when I convert that to moles, I've hit the ideal ratio. I'm making maybe a little more. This is more has to do with the acid-base chemistry that's going on there because it's weak acid, weak base, doing some equilibrium stuff. But this is pretty much the most you're going to get out of the reaction. That's where we can use that value to get the coefficients on the reaction. There's details in the lab, which I don't have time to go over, but you'll see it in the lab. Change that to moles, you can get to the balanced equation. You can also evaluate citric acid before that point, citric acid at that point, citric acid at the beyond that point. So before this nice, perfect balanced point, we had limiting factor of citric acid and excess of baking soda. After that point, we had excess of citric acid because we kept putting in more citric acid and not getting much more product. And then the limiting factor suddenly became baking soda, and then neither are limiting or excess at the ideal proportion here. And then, so students can do the quantitative analysis and get the moles and get the coefficients of the reaction, or they can talk about it just in terms of living and excess reactant just by looking at the graph. So there's that lab. And let's go back to the presentation. Whoops. Sorry about that. I'm getting there. Okay. So that's one way to use the pressure sensor. Another, where we did the shared session. Remember, this is a screenshot of the resource that's in the shared files. It's just a handout you can keep handy, make a class set or whatever for your students. Before we go on, I wanted to talk about more saving and sharing options besides saving to your device or sending to your cloud or doing a shared session. So you can save, once you save that SPARKlab, like you guys have the SPARKlab on your devices now, those of you that joined my shared session, again, you can save that and send it to anybody. You can open on any device that has SPARKvue on it, or go to the browser and open it from the browser. You can also do a screenshot. Here are the shortcuts for all the different, for the popular devices. Windows, it's Windows Shift S for screenshot. Mac is that, I don't know what that symbol's called, Shift 4. For your Chromebooks, your Chromebook shortcut to get a screenshot is Shift, Control, and that funky symbol that's at the top row of the keys. It's kind of right in the middle of your top row keys. That's a screenshot shortcut key. Shift, Control, screenshot shortcut key. So I would recommend, if I was still in the classroom, I would have students do screenshots of their analyzed data and drop it in a Google Doc, or drop it in their Google Doc version of their lab write-up that you would get from the lab manual. That's what I would do. If I was in the classroom, you have whatever works for you. Another way to share data, you can export to Excel as a CSV file and import it into Excel and do whatever else you want to do in Excel. For example, here's how you would do that for this lab, or any lab, as long as you have data. You would go up to the hamburger menu and do export data. When you click export data, it's going to save it as a CSV file. You type whatever you want for the file name and save it. CSV can be sent to a Google Sheet or Excel or many other programs. But that is how you can get data out of SPARKvue and into another program if you like. Can you do the delta for each curve trial and save it? Yes, you can. Oh, the delta, yeah. So let's go back here. So the question was, can we do a delta for each curve and save it? Yes. So first I want to do the orange run. So I'm going to pick the coordinate point tool. Let's do a delta there. We're just going to do a couple. So there's that. There's a delta 5.5. I'm going to skip to the red run. So I changed to the red run. I'm going to do my coordinate there. So you see how it saved. Whoops. See, that happens every now and then. We're going to use the delta tool here. And I can move that to wherever makes sense. Stuff is movable because there's always stuff in the way, right? So stuff is movable. Oops. My delta looks like it's over here. I'm having screen issues right now. Sometimes when I have a lot of monitors and cameras streaming, I get a little bit of a visual interference on my screen. Let me try that again and see if it fixes itself. Let me pick a different one and go back. So try that again. I think I had the wrong tool on too. So let me turn on that delta tool. My initial, there it is. Yeah, it came back. I just tried it again. It came back. Here's my 15.8. And my 5, it's in shadow, but that's the 5.5 from the original run there. But yeah, it'll save multiples. You just have to make sure that you're switching runs. And then when you save it, whatever you've done previously, you should be able to close and reopen, and all of that analysis will be there. Oops. I'm having real memory issues right now. Too many cameras and things hooked up. Totally got some memory stuff going on. Okay, well, I'm having issues with memory, so I'm going to not show that. But yeah, you just like before I showed you with the graph from the evaporation, you can do any analysis, even if it's multiple selections on multiple runs. Like the screenshot here showing you these two slopes, or rather tangent tools on these two runs. This came as a saved file in the titration here. Okay, now going to my presentation again to make sure I'm covering everything. I talked about this quick reference files and the references in the shared files. You'll find we keep updating this because we get more and more and more stuff in SPARKvue and keep track of it. SPARKvue help. If you go to help.sparkvue.com, and I'm going to put that in the chat, it goes specifically to the help. Oh, sorry, it's help.pasco.com/Sparkvue. Said that wrong. So here's where that goes. This is actually, you can get here either by going to the web address that I just gave you, or if you're in SPARKvue, you can go to the hamburger menu and go to help, and it goes there too. So that's how you get to SPARKvue help, either from within the software, from the hamburger menu, or by going straight to the website, help.pasco.com/Sparkvue. So this is one way to get help. You can search in here. Let's say we're looking for coordinate tool. Find data coordinates. There, it takes you there. It gives you screenshots. It's very highly structured, very useful and helpful, and what to do when you got more than one run and so on. All the questions that we know students ask because we've been there and done that. And you tell us too, and let us know what things need to be added to our help. Like you need a little bit more support on something else, just let us know and we'll add it. Or we could add it. Or we can point you to where to find more information on it. So tons of help here in the help, but also not only there, but if you go to portal or pasco.com, I'm going to show pasco.com. Let me bring that up on a separate screen. So going to pasco.com, some help here, go to resources. You've got experiments you can look up besides what's in Essential Chemistry. You can go to the video library and search videos for anything SPARKvue related or other software related or product related. Or just hit the search icon here. There's also some help in book-specific help. Let me go there. As if you attended session 1, you've seen this already. So from Portal, and you go to your essential chemistry curriculum through the menu, because the oh, my screen's not refreshing again. It's my too many things hooked up going on. The support rather. Actually, let's go this way. So we're going to curriculum PASCO Essential Science, and we want book-specific stuff, and that includes the labs, like the labs we just did, because they're out of the essential chemistry curriculum. There is these helpful videos on the bottom here, video guides, and then we can browse more. I think there's one more. There's the equation builder. So there's helpful videos here for the ebooks. Also for on support, you'll find some more where I'm looking for, sorry, it's in the professional learning. In professional learning, there are how do I videos and video tutorials that help you get through the essential chemistry specific things or essential physics and the software. So lots and lots of support for you. We can help you find things too if you go to pasco.com and open up a chat. We got live help every day from 7 a.m., I believe, 7 a.m. to 4 p.m. Pacific time. Someone's there to help you. Not a bot. Okay. Next. Go back to my presentation. Okay, yeah. It looks like we'll have time to do Boyle's Law and a little bit about the Boyle's Law and a little bit about the pH sensor, but we won't have time to do that physical chemical change. However, I want to point out I didn't have time. I'm not going to have time to do that physical or chemical change thing, but what you can do, because I didn't have time to go through it, you can go from Portal. I'm going to show both Portal and Education at PASCO.com. You can go to Curriculum, PASCO Academy, and PASCO Academy, as we discussed in session 1, has a chemistry section that you have access to if you're a Portal subscriber or if you're an ebook subscriber, and you go to, where is it? Physical or chemical change, investigation 3C. Here it is. Here's classifying matter. There's the lab I didn't have time to do. Here is the student-facing video, which is myself and Roger as lab partners doing the lab that I didn't get to go over. You can watch it here. Here's how to do the lab. Here's the data. This is actual data. And then the teacher-facing video just says, here's what we're doing in this lab. Here's all the things you're going to need. Here's the things students need to know, and so on. And then you can have students actually do the lab asynchronously. And then if you want to show the follow-up video, you can after they've turned in their work and thought about that lab. So you do have the opportunity to see me do the lab. It's just here in an academy, plus 20-something other labs that are part of the essential chemistry curriculum in PASCO Academy chemistry. Look at all these topics. These are all labs that are in essential chemistry. So you have your choice of a full years of curriculum of labs from essential chemistry. So you can use this either, like it's great for a sub day, or even if you're for your own professional development, you're like, I don't remember how to use pressure sensor. I'm going to look at that stoichiometry lab again. Here it is, 8D, determining limiting reactants. Okay, so here's how to get there if you're going through education.pasco.com. Let's say you don't have Portal, but you have the ebook. Here's how you get there. You just, on your landing page here from the teacher login, there's a button right there for Academy. And there's the same exact series of labs, investigation 3C, physical change. And then the stoichiometry one, the determining limiting reactants, there it is right there. So there you are. All the videos and the files that go with it. Okay, so that's some nice resources for you. Besides help, we've got the labs, many of them, the most popular ones, and the whole full year available for you on Academy. Okay, we're going to do the Boyle's Law lab. We talked about slope. We're going to do a different kind of fit for Boyle's Law. Okay, so it's not going to be a linear fit. We're going to try a different one. Let's see how that lab looks. Oops, I meant to not do that. We'll want to go to the PDF. So here's one way another way students can turn in work. You went to the resources for the lab. Okay. Well, I brought up this lab. This was the one we did first, the evaporative cooling. This is a PDF. So all the PDFs are fillable PDFs. So you send it to student, the student can type in their name. They can type in their answers, blah, 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 put in their data and so on, and then save it and upload it to you. But this is one way of doing it. Another way of doing it, of students being able to send their lab to you paperlessly is like, here's a Google Doc. Students can put in their data for Boyle's Law, which we're going to do. You can type in to the document. And then for the graph, you can just do a screenshot and paste over this and then answer the questions directly into the document. And students can, if you use Google Classroom, there's a good option. Or if you have ability to use Google, you can use that option. So let's go and do Boyle's Law. That lab in SPARKvue is 12B. So open PASCO experiment, essential chemistry, 12B. I'm going to kind of go fast through this one. Okay, for time's sake. So the syringe comes with your equipment. This time we're using the pressure sensor and it connects directly to the syringe, and you don't want to over tighten that. The lab says to start at 30 milliliters. So the bottom plunger lines up on the 30 milliliter line to begin. Okay, let's connect the sensor. And this time every time so far when we've done data collection, the timer kept going and it just kept collecting data points over time. But this time we're doing something called manual sampling. It's preset for you with a table and graph. Students will start with a volume of 60 milliliters and record the pressure. So you don't want the sensor to keep recording data. You need manual entry. So you'll click the button only when you want it to save data. That's what manual mode is. So we're going to hit start. And see, I have to hit the check mark for it to keep that data. I got to move my plunger to get a volume of 60, and my data might not be beautiful because I'm working with one hand. Okay, so it's stabilized. Now I'm going to go to 55 and let it stabilize my pressure, and then my 50 value. And look, it's drawing the graph for me, going to 45 milliliters. And we can already see kind of a trend with data and pressure and volume and the relationship between pressure and volume, but it's not linear, right? It's like curved. And keep that data point. I'm gonna go to 30. Now you can see why we started at 30, because we had to expand all the way to 60. And we're going all the way down to 15 milliliters on the syringe. So 25. This part's hard for me because I have tiny hands and it's hard to do this part. I might only get to 20 milliliters. We'll see what happens. And then, oh my goodness, here we go. 15. This is probably going to be an ugly data point. You see her shaking. Okay, and there I got my last data point. And notice how every time I hit the check mark, it made the number turn black and the next one turn red. So your last data point, make sure that you've recorded it, make sure that it's black. And then it goes to the next line. Red means not recorded yet, or whatever color your run is, so it's red. It's going to say not recorded if it's that color, recorded if it's black, so make sure you've got that last value and then hit stop. And now we're going to do some mathematical modeling again. So you can stop it here. You know, if you're satisfied, you just want students to be able to see this inverse relationship and scale it, you know, that's nice. What happens with the pressure and volume? What's the relationship here between P and V? This is Boyle's Law. You can leave it at that, or you can go the mathematical model route and you open up your your curve fits menu and look through all these options and start picking choices that could be your data. You know what? It could be quadratic. Let's see. Nope, not that one. Okay, let's try power. I mean, it's not that same direction, but it's kind of a mirror image. Does that work? No, not so much. It doesn't overlap really well. There's probably a better fit. Well, let's look at inverse. You know, it kind of looks like that. Ooh, look at that. Okay, this is a good model probably, but we do want to evaluate the rest of them so they can try the other fits. They eventually find that, yeah, inverse fit is the right fit. What's my math? My math says y equals a over x plus b. Y, pressure, x, volume. So A is a constant. The constant here is 2970. So with a little bit of math, when you take, let me open a calculator here. When you take 60 times 52.8, you get about that number. 2970 is really close to 3168. What happens when I do 25 times 121.6? That 3040 is very close to 2970. Okay, so that means I can use this line to predict if my volume was 28, what would the pressure be? Well, where's volume in the formula? Volume is X. So plug in your 28 down here, plug in your value for A, 2970 up here. So do some math, do some prediction. A over X, so that's 2970 divided by X. We said we were predicting what's the volume, what is the pressure at the volume of 28 milliliters. Okay, we can predict that the pressure would be 106.07. And let's see if that matches up with the graph, what the graph shows. Here is another tool I can use. This is to draw a prediction, this pencil icon, but you can also do it too when you're doing something like making a prediction on what a value will be. It's kind of there. It's close. I got 110 on a poorly drawn line, and the prediction says 106.07, so it's a decent fit. This is a decent model. I just realized that I forgot to, B, by the way, is the y-intercept, but there's no such thing as zero volume in this case, so it doesn't make sense for there to be a y-intercept. It'll never hit zero volume, so you just drop B out of the equation as a zero. Mean square error, you want that as close to zero as possible, and the mean square error also is how you evaluate the goodness of fit here. I forgot to tell you about the annotation tool. So that letter T. So remember when I squished the bottle that had the pressure recording on it? I'm going to add this nonsensical squish bottle note here, and we're going to pretend this is a different data set. So you can add a note and attach it to a data point to annotate some anomalous data, like say what happened, to report any anomalies in your data. And that can be something that will save to your experiment. Okay, so here was the summary of using that fit in the Boyle's Law investigation we just did. And then we don't have time to talk about this one, but I would recommend looking at this in PASCO Academy. We have just enough time. Linear fit, we talked about this previously, and here's just a summary of the linear fit. We talked about that when we did 11A. Conductivity and pH sensor use tips. I'm going to switch out this equipment here. And we have just enough time to use the pH sensor and talk about the key points of sensors like that. So the pH sensor comes in a storage bottle with a note on it that says it's 4 molar KCl, but it doesn't tell you this, but you should know that this is not distilled water. This is 4 molar potassium chloride buffered at pH 4. So you can either buy more solution from us or make your own. It's 4 molar KCl in a buffered pH 4 solution. Don't put just distilled water in here. That will ruin your probe and that will void your warranty. So not distilled water, it's 4 molar KCl buffered at pH 4. There is a few things in the essential chemistry book where you're not going to use the experiment file, or maybe you just want to do an investigation on the fly. Here's what you do for that. You turn the sensor on and you go, instead of going to PASCO experiment because it's not associated, it's maybe something that's not a lab, that's EC, essential chemistry lab, go to sensor data instead. That's the button right in the middle. Sorry, I went fast there. There's sensor data. Click that button and then connect the sensor there. I don't need pressure anymore, so I'm going to disconnect it. I'm going to touch pH to connect it. And now I can pick a display over here or a pre-built experiment. I'm going to pick the pH of common substances experiment because that's what's appropriate for the activity we're going to do right now because we're going to test the pH of these substances. So this is another manual sampling. I'm going to hit start. And using the pH sensor, since I'm using test tubes, I'm going to either want to roll this up the probe or I'm going to take it off completely. I recommend rolling up the probe and watch what I'm doing here. I'm not twisting anything as I'm, these two things, I'm not twisting opposite. I'm pushing up only because if I twist that, I might break the electronics. I want to avoid doing that. So now I'm going to rinse with distilled water. I'm going to swish and then tap water and rinse again before I even test anything. And then I can blot gently with a paper towel if I want. I know we're running out of time, so if you got to run, go for it. I'm going to wrap up here in a couple minutes. And remember, I'll send you the recording to the email address you signed up with if you got to run. So if you got to run, thanks for joining us. Otherwise, I'm going to continue with this investigation. So tap water. So I rinsed before putting in the first test substance. This is tap water. And there's a little black piece at the bottom of the probe. Make sure that that's submerged. That's plenty for you to be able to get data. Let it stabilize, hit the check mark. It gives me the numeric value as well as the visual bar graph. Okay, so I got my first value. I'm going to rinse. I like to swish. This is very good idea here to get as much cleaning as possible. Just have some tap water to the side and blot. These two blue substances, one of them's Gatorade and one of them's window cleaner. Which one can you drink? Well, this one has a pH of 3.15. That's probably food. And by the way, where it says bar 1 and bar 2 here, you can edit those and put text there. Bar 3 is window cleaner. And by the way, you don't want to do something like bleach. It's just far too powerful. You just have to dilute it. I would do like a 4 to 1, or sorry, 1 dilution. Okay, acids, yes, you can do acids and bases. You can do like 0.1 molar, but I wouldn't go higher than that. Okay, that was window cleaner, 10.58. It's a bit lower than I expected because that's ammonia-based. And then rinsing, swish, rinsing, blotting to get our final substance, apple cider vinegar. So this activity is like a pH of common household substances investigation. That is not part of the lab book. It's actually in the essential chemistry curriculum as a side activity that's in the textbook. And it is chapter 16, section 2 in the book. So when you're looking in the book and you're looking at the resources, you can find that activity here, chapter 16, section 2. It's called pH of household chemicals. So that's how you use the pH sensor. Again, no time to use to do lab 3, but the conductivity sensor is similar, where you rinse, swish, rinse, and blot before you test substances there. We just did that lab. On your own, you're going to want to look at the pH probe storage tips. It's too much information to remember now, but at the beginning and end of school year, evaluate these tips and make sure that you're taking top-notch care of your sensor, and it'll last you a long time. Okay. And remember, there's that sheet I gave you on take care of that pH sensor. It's in the resources folder in the shared files. When you need to clean sensors, the pink sections here, come to this slide, look at the pink sections, and it says, here's places where you don't want to get wet. Everything else you can wipe with a sanitizing wipe. Temperature sensor is like bulletproof, right? But there are some areas on other sensors that you want to avoid. And make sure everything is off and unplugged when you're cleaning. We talked about battery types already, chargeable versus non-chargeable. We talked about Academy, and if you have any additional questions, please contact your regional PASCO rep if you're interested, like in maybe you're interested in Portal or anything else that you saw on here. Maybe you're not yet an Essential Chemistry subscriber, but you want to be now. I hope so. So anyway, this is, I'm going to put this link in chat. And I thank you all for being here.